This is obviously a free webinar hosted by ourselves, ARC Building Solutions. I'll go into a little bit of detail today about our new products, so the retrofit Eaves Insulators. We've got 3 of those now, and I did a webinar similar to this a few months ago, but in that one we concentrated a little bit more on the science of it, what thermal bridging is. We will touch on that today, but primarily the point of this webinar is to showcase our full range now. I've worked quite hard over the last few years really to try and diagnose all of the issues that are happening at that Eaves junction, and to produce products which are applicable across most of the housing stock in the UK. So we'll go into some of the details about what is included, what isn't included, some of the things that we need to know to make sure you get specified the correct product, the benefits as well. We'll go into a couple of case studies and a little bit of the science behind it too. At the very end of this, I'll open the floor to questions. You can't talk to me directly, unfortunately, on this platform, but you can put the details in the public chat in the bottom right there, and I'll try and answer a couple of those. If not, as per with us, we love engaging with people, customers, collaborators, other people in the marketplace. So just reach out and we'll definitely be there to support you with any inquiries you might have. So essentially, we're going to be looking to eliminate damp and mould in the Eaves junction, and this is primarily in existing housing stock in the UK. This is us as a company, really, ARC Building Solutions. We've been in operation for over 16 years, and we are award-winning manufacturers of cavity fire barriers and cavity closers. That's traditionally where our experts have been sort of positioned. But now we are developing that expertise in the insulation and ventilation sectors as well. And we're doing that through the development of these projects, but also being really engaged with research and development. The construction industry, I think, is moving on quite fast, and what that can do often is create some problems. So it's our job as manufacturers to stay on top of that development and make sure that we're at the forefront, anticipating what those house builders and the existing housing stock need in order to operate properly. And at the bottom there, you can see, and this is going to be a recurring thing in this webinar, we're protecting people and places. You'll see that at the forefront of everything we do is about making sure that people are safe, but also the buildings are safe if possible. So you'll see that as a recurring theme. So some of the things that are the focus of these products, and this is particular in the Eaves junction. So we've got 3 elements really, and it's important to tease these out slightly. Partially this is because of the cross use of a lot of keywords in the space. So when people talk about ventilation, a lot of the time they're talking about ventilation within the dwelling, within the living space. This is really important, and there are tons of experts out there on this, and we work with a lot of them. But what the Eaves Insulator does, it makes sure that ventilation is maintained in the loft space. So that's what you can see at the top there, that mould in the loft space. What causes that is bad ventilation through the soffit and through the eaves over the wall plate into the cold loft space. This has a couple of negative effects. It can damage belongings. I know myself, I've lived in places before where I've stored things in the loft, maybe a little bit before sort of my expertise in this grew, but you get those little sort of white splodges typically in the loft space, those mold patches, and that's one thing, and it can affect an occupant's belongings, and that's obviously a cause of concern for them, but a cause of concern for a lot of the time for the housing associations and for landlords, and if you're a homeowner, is a cause of damage to the structural integrity of the loft space. That's rafters, joists, even the fabric on the roof, that can all be damaged by bad ventilation. So we'll address that using the Eaves Insulator, and we'll talk about how that is done in this presentation. The second thing on there is mould in the home, and this arguably is the thing that has got a lot more media attention in most recent years. So we had the death of Awabishak, and that has had knock-on effects for housing associations and landlords, which is, I think it's very appropriate to make sure that we're targeting these issues and making sure that that doesn't happen again. The mold in the home was a significant cause of that. So a lot of the time, that mold can cause damage again to the building. That's the protecting places, but also we need to protect those people who are living there. That may be through improvements in the design of the details, and reducing the thermal bridging, and making sure we're aware of thermal bridging when we're upgrading the insulation of buildings, but also maybe educating occupants as well. And that's sort of where we're trying to do more of this public engagement sort of side of things, both installers and occupants and specifiers. We'll go into those legal issues as well that have come out of our Abhishek's death closer to the end of this webinar. The third thing on there, energy efficiency. I think this is the thing that has had the most media attention. Sort of net zero targets by the government, and from those essentially being passed down onto local authorities, needing to improve the housing stock in the UK. It's one of those issues that everyone's trying to tackle. That's the main point of conversation at a lot of the networking events and the conferences. So that's really important. And as I said, we're not going to get into the details of why thermal bridging can get worse when we insulate a home. But that is a fact that it can do. We've seen a lot of issues where we've upgraded the building, spent thousands and thousands on it, but then we have that thermal bridging issue, still have problems with energy efficiency. And at the end of the day, again, that protecting people, we don't want people to have cold homes. So if we can reduce that thermal bridging, reduce that heat escaping, we reduce the bills, we make them warmer, and we can reduce that carbon cost of the home. And at the bottom there, difficult and dangerous. I've done it many times myself now, crawling out onto joists, trying to use crawl boards where I can, where they fit. But installation can be difficult and dangerous of just traditional insulation and a ventilation tray to make sure it's fitted properly. Our products sort of reduce that issue as well. The biggest problem we have, and that I think a lot of specifiers have that are overseeing live projects, is the variation in housing stock. And that is sort of a good thing in a way. I think it's a result of our rich cultural history. We have buildings from, early 20th century, very, very common around the UK. But this does create a problem for us manufacturers where we're trying to create a solution which will be applied across a whole housing stock. It's plug and play market really, and we want to make it easy for specifiers and for installers to make sure that the Eaves junction is correctly treated. So we need to make sure that our products apply to all of that, those housing archetypes. But one thing that is true in the UK is that most houses do have cold lofts, or at least a cold eave section in a converted loft. So even if you have that room in roof detail, a lot of the time you'll have those sort of fake walls, and then behind there an eave space which needs insulating and ventilating. Otherwise, it's going to cause thermal bridging issues underneath, and then you're going to get mold. So that next bullet point is sort of demonstrating all the different variations. So sloped ceilings, where the wall plate sits, if there's purlins there, if it's sarking or membrane that's going over the joists, how the joist and rafter are fixed, is it in plane, out of plane, what are the space in between the rafters, what is the roof pitch. And the good news really is that our product can deal with most of those variations, with the exception of flat and sloped ceilings. Anything from 10 degrees upwards, our products can address. And we've looked at a lot of those details, we've dug into the history, and we're pretty confident that we can solve most issues. So even if you think you have some properties that are outside of that catalogue, let us know. We can try and figure out if we've got a solution for it. I've recently looked at a hip roofing section and a hip roof detail, and because of how we've designed the ventilation trays, it was applicable for that house. It still worked, even though there were 4 or 5 rafter spacings at the end of each run, which were obstructed by the hip roof. So just reach out to us. Historically, with this problem, we've talked to installers and specifiers and retrofit designers, and they've just stuffed insulation into that junction. Or they used to when they weren't quite as aware for the ventilation, and that would just block any air that could get in. We'll go into some of the issues that causes, but you get a well insulated junction, but you have a terribly ventilated loft. Alternatively, they may not put the insulation all the way into that junction to make sure there's some ventilation coming through. You'll see some thermography images that I took of a house that had that solution. Well, call it a solution that created more problems, but they had the ventilation, but the insulation was just so bad that the mold is shocking there. And then finally, the only real actual solution is to buy a separate ventilation tray, stuff insulation into it, and just hope that that's sort of okay. And that is very costly for the installer. It can be very awkward. It isn't applicable to a lot of details, so it's not a solution to the problem. And that's why we've ended up with this range of Eaves insulators. It's not something which is, one size fits all, but we've got these three versions. So going through these, they're all patented products or patent pending. They're all suitable for past 2035 projects as it addresses the ventilation and insulation in a property. It's a very simple solution. You'll see once we've specified what the rafter spacing is and which one of these is appropriate for your building. It's very easy to specify and install. It can be used with any roof pitch above 10 degrees. Otherwise, it's classed as a flat ceiling and it is got different regulations. Easy to install and it's self-contained. Going from left to right, just as a bit of an overview of these. On the far left side, I'm not sure if you can see my cursor, but here we have the Eaves Insulator. This is the traditional Eaves Insulator. It's meant for new build new build homes. The ventilation trays are 600 millimeters wide and it needs to be fixed, as you can see here, on top of the rafter. So this is perfect for new build. We've had all the major house builders are taking this, and it's absolutely perfect for that. Before the roof covering goes on, before the tiles go on, this is an excellent solution. However, historically, those rafter spacings are different. So we have developed these two products, which are the retrofit versions. This one on the left, you can see that's suitable mainly for solid brick houses, so 1 brick thick. That's because it doesn't have the insulation that comes over this detail. And often people who work a lot in lofts will see this, it's blocked off by a wall plate or there's not actually a way to get over here. So that's where this solution is perfect. It gets insulation right up into that corner. And if you're applying external wall insulation, it comes up to the top here. I'll go through the thermal bridging values on this, the psi values, but this is a really, really good solution. Alternatively, if there is the ability to get over the wall plate, which you can see in this setup, this new retrofit wall plate insulator that we've just developed and will be launching in the next month or so is designed to go over that detail, get full insulation, and then you can see this fixing strap. This is folded in on itself and this is fixed to the internal surface of these rafters here. So both of these can be used with any rafter spacing, and it provides ventilation and it gets the detail as insulated as possible. The thing I love about this one, it can be used also for a sloped ceiling. So I've actually got them in my home, or you might have heard them referred to as scaling details, but it can slip down there, and I've got a case study of that and you'll see the effects of it. It's pretty incredible, if I do say so myself. So mold in the loft space. We've sort of discussed this a little bit. If we block those ventilation routes from the soffit into the cold loft, essentially we don't get any fresh air in there. That's all it is. We just need fresh air to be circulating through that loft space. The reason why this is so bad, and it's quite common, especially in older homes again, is when we've got a poorly sealed attic hatch. So to get into that loft ladder, if that's poorly sealed and it's not insulated, moist air that we exhale or moist air from cleaning and cooking, that can get into that loft because of heat rising essentially. If we don't then have fresh air coming through and essentially sort of taking that moist air away, all of that moisture is going to condense on the cold surfaces in that loft space. So it's going to have a very, very moist environment. It's going to be very wet, and then that's going to cause issues. Firstly, mold loves to grow in wet spaces. See that all the time. Secondly, it can get so wet that it actually causes structural damage to the rafters, and that's rafter rot. So, you wouldn't want, if you see a bit of wood on the ground that's been subject to damp for a long time, you step on it or you press on it and it just crumbles to nothing. We don't want that happening with the rafters, obviously, because that's literally the roof above our heads. And finally, if you do have that issue, then it's going to be incredibly expensive to rectify. So the affected rafters will need to be replaced, or there'll be those typical issues of insurers, wanting that roof to be replaced. And I think these images are really nice. That first one, I've got to give props to BPD for this one. So you can see the that wet rafter here and some mold developing at the top in this home. And that just shows sort of how significant that can become. And that is not going to be as strong as it should be and as it needs to be. And then at the bottom here, we've got a detail from NHBC and a detail from LABC. And you can see we're practically looking at our products here. So this is what is needed. So we've got that ventilation tray, and then we've got the insulation that comes over the wall plate. This is easily specified, and we can conform to that using our products. And then it's the same with the LABC detail. We've got that ventilation tray here, and then we've got this insulation coming over. So you can see the benefits already of our products to sort of conforming what these bodies require. This is just reiterating some of those things, but that middle one is the most important one, I think. The changes in the guidance state the retrofit insulation solutions must have a ventilation strategy to be eligible for government funding. That applies to past 2035. So that's your retrofit coordinators and your designers really need to make sure that that ventilation is there. At present, I think the focus is on ventilation within the household, as I say, but we need to make, if that ventilation strategy is not there, we're going to cause a lot more issues potentially than we're solving, because the structural integrity of the building isn't going to be able to cope with that. So now we're getting onto the thermal bridging. So we've covered off ventilation in the roof space and why that's so important, and the mold that's created because of that. Now we've got a separate issue. Now we've got this thermal bridging. So essentially, thermal bridge is where the insulation, there's discontinuities in the insulation. So it might be slightly thinner along the eaves junction. It might be brick ties. There's a lot of different places where thermal bridging occurs. And when we get a thermal bridge, what it causes, in essence, is a cold spot on the internal surfaces in the building. And that's that concerning part. That's the bit that I'm focusing on. You can see at the bottom there, if you've got excessive thermal bridging, the building is going to suffer from damp and mold. If it's using SAP rather than RD SAP, it's going to have a poorer EPC rating. I think RD SAP in time is going to be updated potentially to include this, but that's a larger topic than is appropriate for this webinar, really. But we're also going to receive high bills, so more heat from inside the building is going to be escaping to the outside. We have a really nice video animation for you here, but it just sort of explains the science of it, potentially slightly more concisely than I have.
When upgrading the insulation in a property, it is important to consider any gaps in the insulation created in awkward places, such as the eaves junction where the wall meets the roof. Thermal bridges are areas in the building envelope where heat can pass more easily. At a badly insulated eaves junction, warmth will escape, resulting in a cold spot on the inner surface of the wall. Much like a cool glass on a hot day, water from the air condenses on the cold surface and causes damp. This can result in damage to the wall and mold growth. The ARC Retrofit Eaves Insulator is specifically designed to ensure the internal surfaces are kept warm, significantly reducing damp and the growth of mould. If you're interested in the Arc Retrofit Eaves Insulator or would like more information, please get in touch.
This is the stuff that I think is really important for everyone to be aware of. This is a case study that we did whilst we were developing the retrofit Eaves Insulator, and you can see these are thermal image maps. So this is using a thermography camera, and it's looking at a detail in a bathroom above a lintel across a window there. And you can see on the left, this is prior to the retrofit Eaves Insulator being installed. You can see that blue areas, that's cold patches essentially. So that is significantly colder than the surrounding construction. So you can see on the chart here that it's really quite a significant area. And what causes this roof, a couple of years prior, in the loft they had ventilation issues, so someone had gone in and pulled the insulation back slightly because of that. So they didn't want to have raft rot and the tenants' belongings were getting damaged, so the insulation was pulled back slightly and another layer put on top, and it was done so that the ventilation was fine, but we had this huge gap remaining afterwards. So this was a significantly colder, and what causes the condensation and the damp is, and this is the best way I've found to describe it, cold air can't hold as much water as warm air. So that's where you go into rainforest, and it's really warm and you can have really high humidity. It can be really humid and there's loads of water in the air. But as soon as that gets a little bit colder, that air can't hold as much moisture. So it's one of the causes for getting dew on grass and things like that. It's also why in a cold glass of water we'll get condensation on the outside. The air that has lots of moisture in gets close to the glass, it cools down, can't hold the water anymore, so it condenses. And then this becomes a cycle because that cold air is now going to leave through convection, and warm air is going to come in and it's going to dump more of its water. So that's why you see sometimes with the condensation on your glass, you end up with a huge puddle. Nothing's escaping from your glass, it's actually condensation in the air. And you can see on the right there what's happened when we've installed the retrofit Eaves Insulator. And this did not take me long at all to do this whole house, and it was a bungalow, and it's just incredible. It was quite a low pitch, so I still managed to be able to get into those areas quite safely, and it's done a really good job there. You can see at reducing that. I wish we had images before we did the retrofit Eaves Insulator. Unfortunately, the landlord had recently just done maintenance across the houses, and they'd got rid of that mould, unfortunately, and painted over it. So we don't actually have a picture of, but I've been told that there used to just be a perfect strip of mould across that, and you could see where the rafters were, where the mould hadn't formed. So it's really interesting. Here is another case study that I did over this winter. Those of you who know thermography and thermal simulations will know that you need to have a 20-degree difference between inside and outside, so I had to wait for it to get to 0 degrees. But you can see here, this is the sloped ceiling detail that I was talking about earlier. Sometimes referred to as scaling, and these are so difficult to insulate because this is being screwed on. This plaster has been screwed on or nailed on to the undersides of the rafters. So the only space you've got between the plasterboard and the external roof covering is this. Really, it's really thin. Just the depth of that rafter. But you can see here, I've installed the retrofit wall plate version. Down there, you can see a lovely ventilation path has been maintained. We've got this insulation here in this green bag, and we've got a wall plate that runs the whole length of the building. And that would sit here, the wall plate equivalent. So you can see the insulation comes down and it's sort of situated there. And then the insulation comes up to the bottom of this tray. And then again, the thermography images, you can see that difference. In this version, the best image I got was comparing an insulated section and an uninsulated section, and that difference is, I think, just remarkable. So again, any mold issues there were resolved. Really effective solution in both those scenarios. Again, I'm not going to go into the detail too much of the science of it in this webinar, but the key things are, a lot of people talk about U values. Now, U value is how much heat escapes from a plane element. So your wall, your roof, your floor, windows, they're all plane elements. It's 2D. And that's what your U value measures, how much energy is lost per meter squared Kelvin, so what the temperature difference is. That isn't applicable to thermal bridging. Only psi values are applicable to thermal bridging, and that's a description. Same idea, how much energy is lost per length of that thermal bridge, considering the temperature difference. So is the equivalent, you want a higher U value for plane elements, you want a higher psi value for thermal bridges. That's one element, that's one important number in this topic. The other important number is this temperature factor. Now, temperature factor is really simple, slightly convoluted, really, actually, now that I think about it, but it's a ratio. It's how cold your coldest surface is compared to how warm, theoretically, the warmest surface could be. So it's a really simple calculation, but it's, I think, for some people, can cause a little bit of trouble, confusion. But we want that to be low, which would mean that your coldest area is as close as possible to your warmest area. Sorry, we want that to be nearer 1. So the closer we can get to 1, that's the perfectly insulated building. And here we can see a typical 1 brick thick house and eaves detail. So even though it looks as though we've got 2 elements here, this is actually just the internal and the external brick leaf. And then in the center, we've got this center joint. So if you see 1 brick thick, we've sort of considered the thermal conductivity of the mortar compared with the brick. And this is the most accurate way to simulate that detail. You can also see we have the soffit here, we have the wall plate, and then we've got the ceiling plaster. So this is no insulation. As soon as we've added some insulation, so this is what I'd refer to as a low quality retrofit. We've put in insulation, making sure that there's room for ventilation, but we've not tried using the Eaves Insulator to fully insulate all of this ceiling plaster. And we've applied external wall insulation, but just up to the level of the soffit. Again, low quality retrofit job, really. We'd want to maintain ventilation over here, but we want the insulation to come up to the top of the wall. Here we've got a slightly improved one, and this is your sort of low cost Eaves solution, covering the rest of this plasterboard. Here we've got the soffit insulated as well, which is higher quality external wall insulation job. And then here we've got continuous insulation. So this is more similar to the retrofit Eaves Insulator being installed, that wedge one we saw earlier. And then this is equivalent to one of the 2, either the new build Eaves Insulator or the retrofit wall plate insulator, where we can actually get insulation over that. You can see this is worst case scenario. With using the product, you'd actually get a little bit more insulation from this, but I just wanted a worst case scenario. You can see here some idea of the percent reduction in the psi value and the percent increase in the temperature factor. If I go to the next slide, we've got that illustrated here. We can see from no insulation to loft and wall insulation, we barely get any shift in terms of the thermal bridging. It doesn't make much difference applying all of that insulation to the wall and the loft, as people who understand thermal bridging will appreciate. As soon as you've added that Eaves Insulator, even without insulating the soffit, you get another huge drop. This is the big drop from just using our product. Once we get the soffit insulated, we get another significant drop. So that's the difference a good quality external wall insulation job does. And then here we've got another really significant drop in terms of percentages from this case to this case. And this is using the retrofit wall plate insulator. Here again, you can see a similar pattern in terms of the warmer walls. So the colder the wall is, the colder the wall is, the lower the temperature factor, and the more likely you are to get mold and damp. But here you see this huge jump, and you can see it, we've highlighted it here. So this is where your retrofit Eaves Insulator is installed. We get this big jump. And then here, this is another big jump from using to using the retrofit wall plate insulator, and this is your dream scenario really. This is a really well performing junction, and this is the scenario where you've got a single brick house and you need to make sure that you're reducing that likelihood of mold and damp developing. Same story here, temperature factor, we've got a huge drop and then we've got another huge drop, and you can appreciate, I think, how much cheaper it is to install our products on top of retrofitting insulation into a whole house. It's a really significant thing that you're doing for a relatively low cost. This comes on to that insulate, the condensation point again. Your moist air is going to condense into cold surfaces. And this again is reiterating the risk of mold. So to relate it back to those case studies and that thermal simulation, the lower your psi value, the less likely it is that mold is going to develop because you've got warmer walls. And we need to make sure that we're avoiding this situation at all costs. It's precisely because of our Abhishek. He unfortunately passed away, and we just need to do everything we can to make sure that doesn't happen again. And we've now got legal implications for housing associations, local authorities, and landlords if those issues aren't addressed. And I think it would be difficult to have another layer on top of this, but I think it's easy for this to encourage sort of low-handed maintenance, paint over it with anti-mold paint. That doesn't solve the issue, that only covers it up. If we want to stop that happening again, reduce the maintenance costs, we're going to be wanting to properly insulate that junction, and we can achieve that with our products. In terms of your past 2035 funding, we're trying to get the word out there to the retrofit coordinators, specifiers, and designers that this product is a real asset to those projects, and it'll really improve the sort of attractiveness in terms of ventilation and insulation. Here you can see one of our products being installed in a loft space. As we've said, it's any roof pitch and rafter spacing, as long as it's above 10 degrees for that roof pitch and the rafter spacing. Get in touch, we'll make sure we can do it. In terms of our standard product line, it's between 300 and 600 millimeters. If you find anything outside of that, please tell me, because I've never seen it, and it'd be an interesting challenge. So just let me know and we'll figure out how we can do that. So in terms of when to use each of these products, when you're removing the roof coverings and the tiles and your rafter spacing is 600 millimeters, use the arc Eaves Insulator, and that is fixed to the top of the rafters. If there any rafter spacing but you can't remove the coverings on the wall, the tiles and the roof membrane, and you can't get over that wall plate sufficiently well to maintain that ventilation, use the retrofit Eaves Insulator. It's really good for that old housing stock. And then use the arc retrofit wall plate insulator when you're trying to get over that wall plate, and you can get access from internally. That's the best application for that and for those sloped ceilings. Here again, we're just covering each of the different elements. So this is that render again. So that's the arc Eaves Insulator. And this massively improves the separating and the thermal bridging. Here's the retrofit Eaves Insulator again. Seeing that solid brick, you're not going to be able to get your insulation over here whilst maintaining ventilation. So this really effectively addresses those details, and again, it considers ventilation and insulation. And then finally, this new product we're launching, the retrofit wall plate insulator. I'm really excited for this one to go live, and you can see here you get that beautiful continuous insulation down to your sock at the top of the cavity for fire reasons. Each of the products are very easy to install, and it's got really good instructions that come with each of the packs. So your installers on site will be able to make sure that they're installing it correctly. We've also got QR codes which take you to more information if needed. And that's it, really. That covers off everything that I wanted to cover today. I hope it was helpful. I'll just have a quick look now for questions. If there's any other ones, put it in that chat in the bottom right, and I'll get to them. So Matthew, are there any U values on these? As I said, hopefully I addressed that halfway through in relation to the psi value being relevant for thermal bridging. In terms of U values, you can't really calculate those on thermal bridges at details. We would be able to figure them out for you if needs be, if you get in touch for plain elements, but this stresses the psi value. See that someone is typing, so I'll wait with bated breath if that gets posted in the next couple of minutes. But yeah, as I said, if there are anything else, any larger inquiries, please get in touch. I'd be more than happy to assist. As I say, I've sort of developed these from the ground up, so I'm very aware of each of the issues and how it needs to be used. But also get in touch with our customer support team or our external sales team. They're both au fait with all of these things, and they'll be able to help you get the right thing specified. So yeah, thank you very much.